Hello, my name is Anthony, and today I'll be providing you a short tutorial on how to use one of the latest tools to the WhiteboxTools library, the Filter LiDAR tool. The Filter LiDAR tool is located within the Whitebox General Toolset extension and the LiDAR Remote Sensing extension. This tool requires a software license from Whitebox Geospatial to use. In today's tutorial, I'll be providing you a little bit of a background on how to use the tool, the parameters, and then I'll give you a demonstration on when to do different filtering example that is possible with this tool. But before we get into that, we need to first understand the tool. So to do that, navigate to the WhiteboxTools user manual. On the table of contents, find LiDAR tools, and then go to the tool of interest, which is the Filter LiDAR tool. The Filter LiDAR tool is a powerful tool for filtering points within a LiDAR point cloud based on point properties. The neat thing about this tool is you can actually interact with the filtering through complex or not so complex filtering statements in which points are either included or excluded from the output by creating conditional filter statements. These statements must follow basic Rust syntax and evaluate to a Boolean. The LiDAR point cloud properties that you can filter are seen below in the user manual. You could filter based on X, Y, Z coordinates, intensity values, point number return, if it's an only return, if it's a late return. You could filter based on class, for example. So let's say you only want to do filter based on class 2, which is ground. If you could see if the point is a classified noise value, if the point's an overlap, you could filter based on scan angle. You could filter based on point time, point GPS time. Another interesting another interesting LiDAR point property that you can filter based on is the min, midpoint, and maximum X, Y, and Z value, so you can create different shapes in which you want to filter these points. Next, you can filter based on a distance to a point or a distance to a line or even a line segment. Lastly, you can create a bounding box through with the within rect call, in which you can, if the point falls within the bounds of a 2D or 3D rectangle, it will be filtered. So that is a little bit of a background on the tool itself. Now let's actually get to an example of running it, and to do so, we're going to want to access WhiteboxRunner. So navigate to your terminal and then change directory to the location where your Whitebox environment is. For me, that's in a folder called Anthony WBT and a subfolder called WBT. And then once in there, you're going to want to type the command Python 3 wbrunner.py to launch the WhiteboxRunner front end. Once the front end launches, you're going to want to interact. You're going to want to find the tool either by searching for it here or accessing it through the toolbox itself. So I'm going to access through the LiDAR toolbox, and there's the Filter LiDAR tool. The first input parameter is the input LiDAR point. So let's go ahead and put a test LiDAR point file as for this example. We're going to call it, and next we're going to call the output test new.last. And for the statement we're going to do today, so let's do if a Z value is less than 250 meters and it's not noise and it's an early return. So basically points that are less than 250 or retained, anything above 250 is removed. That point is not a noise point, not classified noise, so class 7 or 8, and is an early return. So let's go ahead and run that. Just going to pause the video as well to save a bit of time. So the tool ran in about 38 seconds, which is fairly quick. So before I actually show you the output of the tool, I'm just going to run another iteration of the Filter LiDAR tool using a different filtering statement, and then we'll look at the outputs after. So I'm just going to quickly change the name of the output file to test new 1, 2, 3, and then let's enter a new statement. Okay, let's filter only ground points, and we want to do a distance to the midpoint Y and the midpoint X. Sorry, the midpoint X and the midpoint Y that are within 300 meters. So sorry, I said that wrong, but basically, let me just write it out first. Basically, any ground points that are within 300 meters of the midpoint X and the midpoint Y location. So this is actually create a shape. It should create a circle in the output LiDAR file. So any ground points that are within 300 meters of the mid X and the mid Y. So once again, I'm going to run this tool, and I'm just going to pause the output just in the essence of time. So that tool ran in about 37 seconds, once again, fairly quick. So now let's actually go view the outputs of these LiDAR files. So to do that, I actually use a site called class.io. It's a online, it's a website that's a free online website that allows you to input your LAS files and actually view them quickly. So this is the test LiDAR data set that we use. So you can see this LiDAR data set has some forests, it has some buildings, it's probably a farm, a silo, and it's also got some transmission lines. So this is a good test data set. So the first file that we ran, if you recall, was the test_new LAS. So this was LiDAR points that were less than 250 meters, were not noise, and early returns. So you could see, for example, these are the points that are not noise, early returns, and then are 250 meters or less. So you can see that from the forests, especially, sorry, it's a little tough to view this as my mouse is not agreeing with me. So you can see the forests themselves, the trees have actually been almost chopped down in the sense that the tops of the trees, which were above 250 meters, have been removed as we filtered them away. And also there's no noise points, classified noise points. So if you can look underneath the tile, which might be a bit tough, we don't have any classified noise points below, and these once again are all early returns. So let's go ahead and load the second example, which was test_new_123. And there you go. We have a giant hole in the LiDAR file in which 300 meters from the mid X and mid Y location. So as you can see, this did quite well. You might think of an example where you maybe only want to filter a certain point of the LiDAR tile. So this would go ahead and do that. Once again, we've only scratched the surface of the possibilities of the LiDAR point cloud functionality that you can filter with. Once again, those are all documented in the WhiteboxTools user manual. This tool is extremely robust and very powerful. It has functionality not quite seen to WhiteboxTools to date, and this makes for a very interesting tool. Thank you very much for watching this video. If you have any questions, please feel free to ask those down below.